Okay, ladies and gentlemen, let's double check to see if our audio is working. Okay, nope, it's working. We're not on mute. Good. Okay, so yesterday, ladies and gentlemen, what did we talk about and cover? 3 things, is that right? We covered the what? What did we cover? What's in your notes? We covered the mean. What else? Variance and standard deviation for probability distribution. We also mentioned that the mean, this mu, this is a Greek letter, right? This is the Greek letter for the mean. This is also known as the expected value. Okay? So, on your homework, if I go to the browser, I gave you probability. It's statistics lecture 9 here, distributions here. Okay? And, hopefully you guys get started on your homework ASAP. But what's always, somebody always asks the question for number 14. So I want to go through number 14 with you guys and show you guys how you go about, answering this kind of question here. Okay? Number 14. You say, well, what's interesting about 14? Do you guys see what's very interesting about number 14? When you read it, you go through that and you see what the prize is. Prizes, that is not singular. That is what? Plural. The prizes that can be won in a sweepstakes are listed below, together with the chances of winning each one. So these are multiple prizes in a sweepstakes. So as we look at how to handle this situation in terms of a probability distribution here, if I can go back here. Okay, let's go to the iPad. So for number 14, we have to list the outcomes. And you say, what in the world are the outcomes? Well, how many prizes do you have in that? Because remember, in any sort of gambling game, what's the deal? You can win or you guys can lose in this situation. Is that true? You can win or you can lose. So for number 14, what does it say to you guys? All right, what does it say? When you win, what kind of winning? You have a first prize. Is that true? So the first prize, you got multiple ways to win. You got first prize. What else do you have? Second prize. Is that true? Anything else? First prize, second prize. What else? Third prize. There's 3 prizes? In fact, there's more. Aren't there 4 prizes? Multiple ways to win. Multiple ways to lose. Or no, only there's 4 prizes. And so what I want to do here is share with you guys how to go about that. So if you go to the iPad, let's list the 4 prizes. Those are your outcomes. That's X. And then you have a probability for each prize. Okay? So we're going to look at this situation here for you guys today. You're going to see the deal. First prize, what's the chance of winning that first prize? 1 in, what does it say? 8,300. So I'm going to put that down here. 1 in 8,300 for the first prize, okay? And now we're going to do that for every prize because it's listing the prizes and we want to list the probability of winning for each one. The next prize is a 1 in 5,300 chance, right? And then what's the next one? 1 in what? 4,600 chance. And then the last prize is what? 1 in what? 2,700 chance. So double check, ladies and gentlemen, as you read this. This is the probability of winning each prize. You got 4 prizes there. So there's 2 ways to win, or sorry, not 2 ways. There's 2 outcomes. You win or lose, but there's 4 winning ways now. Okay, now here's the deal. To lose, what's the story about losing? How do we find the probability of losing? Anybody know? Wish I had my sound effects. Well, how do we find, because these are my outcomes and then this is the probability. We're setting up a probability distribution because we're going to use our formula for expected value, right? We're going to use that formula. So we have X. These are all my X values and these are my P of X values. These are probabilities. So how do we go about doing this, ladies and gentlemen? This is the homework question, probability values. How do I find the probability of losing now? Okay, there's first, second, third, 4 ways to win. And then how many ways to lose? Well, what's the probability of losing? 1 minus what? 1 over 8,300. Is that right? Minus 1 over what? 5,300. Minus 1 over 4,600. Minus 1 over 2,700. Isn't it the complement? In other words, the complement of winning is losing. So in other words, the chance you lose is 1 minus all of those probability values. Is that right? Okay, you guys remember that? Use the complement rule. There it is there. But this, I hate to say, we're going to have to use our calculator. Well, it's a good thing we have a calculator, don't you guys think? It's a good thing. So let's find that numerical value in our TI, okay? Let's find the probability of losing now. So we're going to scroll. We're going to clear this out from the trig class. 1 minus 1 divided by, what's that first probability? Isn't that 1 over 8,300? Is that right? Minus the second probability. What's that? 1 over what? 5,300. Minus the third probability. 1 over what? 4,600? Okay. Minus the last one. 1 over what? 2,700, okay? And ladies and gentlemen, what do you guys see? This is a numerical value. Let's go out to the nearest 10,000s. Or, hey, we could do the thousands. That's fine. What's that probability? In 0.999 to the thousands? Okay, you guys okay with that? So what I'm going to emphasize to you guys is we got the numerical value for the probability, bless you, of losing. Now, maybe, you don't have to, but maybe, okay. You can get the rest of the numerical values, but we might leave it this way. Okay, we might leave it. Let's see how to go about using this way. this expected value definition from yesterday. Because remember what we got to do? We got to take every outcome and we multiply it by the probability, and then we add them. We do that for every value of x. Easy breezy, lemon squeezy. All right, ladies and gentlemen. Okay, now, here's the thing. What do we have to do, though? Do you remember from yesterday? What do we got to do? Every prize has to have a numerical value. How do we find that numerical value from yesterday? Let's go to the browser. What does it say? Let's read. The question is this: find the expected value of the amount won for one entry if the cost of entering is 65 cents. What does that mean? You play this game, what does it cost you to play? And how do you know it costs you 65 cents? Because it says it. Okay, that's how much you lose if you lose. You guys agree with that? The cost of the game is what you lose if you lose. So in other words, we get to associate losing with what number? Ladies and gentlemen, you got to write 65 cents as a decimal. That's the dollar representation, right? That's 0.65. So we need that. Don't forget. Why do we need that dollar amount to start? Because for all the prizes now, we're going to have to go with the what? What was that word from yesterday? Remember this word? For every prize, if you win first, second, or third, they're different dollar amounts. We got to go with the net. Is that true? All right. So you go, okay, you go with the net. All right. Well, what's the deal with the first prize? What's the value? What do they say? $4,800. But what's the situation, ladies and gentlemen? $4,800. It's $4,800 minus your what? 65 cents, okay? So what is that net going to be? $4,799 and what? 35 cents. You guys agree with that? That's what you have to write down for the first prize. Here's the deal. That's what you netted. It's always the net. So if you go back and you read further, what was the second prize value? Second prize is how much? What does it say for second prize? I wish I had my sound effects. What is the second prize? Okay, it's not really 1,700 though, because why? Why is that? 1,700 minus the 65 cents. What does that end up giving you? 16 what? Yeah, let me move my word win, and that's going to be now $1,699 and what? 35 cents. Easy peasy lemon squeezy. Okay. Now you might say, okay, well, what about the next prize? What about third prize? It's not 900, even though they say we're going to give you $900. What is it? What is the net? Can you guys do this arithmetic in your head? 900 minus 65 cents. What's that going to be? 900 minus 65 cents. 900 minus what? What is that? $8.99 what? $8.99.35. Is that right? That's third prize. That's the net. Now, what about the last prize? What about the last prize, ladies and gentlemen? Let's go back to the browser. You don't win 300. They say you win 300. You're netting how much? Can you do that arithmetic? 299.35. Is that true? What if you said, no, Mr. Judge, I'm going to have to bring out my calculator. 300 minus how many? 65 cents. That netted 299.35. Okay, you've got your calculator. So there you go, ladies and gentlemen. Now, x times p of x. So what do we do to get that column? Do you guys remember? We got to take the amount. What's the amount? 4799.35 times the probability of 1 over 8,300. Is that right? I think so. We take the next dollar amount. 1699.35 times the probability of 1 over 5,300. And then we get 899.35 times 1 over 4,600. Then you take the 299 times 35 times 1 over what? 2,700. And then we end, we don't want to forget this losing stuff. Okay, so there's the deal. What's the losing situation? Minus 0.65 times 0.999. That's off the charts there. So this is the computation you have to do. And the good news is we do it in our what? In our calculators. You go, boy, Mr. Judge, I'm glad I have a calculator. I know. Because what's that definition of expected value? I'm going to have to take this kind of arithmetic. Do you guys remember? That number, 4799.35 times 1, because you're multiplying, it's a decimal times a fraction. But you could kind of think of that decimal as a numerator. So you multiply numerators. Anything times 1 is itself. Here's my point. That product, isn't that going to be 4799.35 divided by what? 8,300. Plus, now do the next one. 699.35 times 1 over 5,300. Well, that's going to be 699.35 divided by 5,300. Do the next one. What's the next one? 899.35 times 1 over 4,600. What does that become? And then what's the last one? 299.35 divided by 2,700. And don't forget the losing. What's the losing? Minus 65 times 0.999. So, ladies and gentlemen, that's what we're going to have to punch in our calculator to get that expected value for the last homework question, number 14, which was even. And, this is how you approach it. But, I didn't go over a multiple price situation. Here it is, a multiple price situation for you guys. So the rest is TI. So remember, the work is really following the definition because your calculator does the math. You guys ready to do the math on this one? You guys ready to punch that in? Punch the first fraction in. 4799 point what? 35 divided by 8,300 plus, now the next one, 1699.35 divided by what? 5,300 plus 899.35. What do you divide by here? 4,600 plus 299 point what? 35 divided by 2,700 minus 0.65 times 0.999. Okay? And when you hit enter, since this is money, where do you think you guys want to approximate to? You want to approximate to what? The nearest penny. What is this approximated to the nearest penny? Where's the penny position in a decimal? Hundreds. Okay, so approximate to the hundreds. What do you guys get when you approximate to the hundreds? 0.56? 0.56? Is that true? And so, ladies and gentlemen, there you go. It's like, what? 56 cents? Was that positive? That's not a good gambling game. Positive? 0.56? Let's look at the browser. Sure enough, we're right. This game, as a gambling game, is not a good gambling game for a casino. Does anybody want to tell me why? Because this is the answer that they give us in 14. Yeah, it's positive. Good. Absolutely. That's the reason why it's not a great gambling for the casino. For the player, it's wonderful. You know, so really what's happening, again, this is what's called a positive expected value game. So like everybody who plays this game gets 56 cents. That's the long run average. That's the summary. So you play the game. Oh, here's your 56 cents. Great. You play the game. Here's your 56 cents. So for the casino, they don't like that. That wouldn't be, whoever designed this game would be fired in the casino. Why? Because it's not a negative expected value. Casinos need that to be a negative. In other words, they want you contributing money all the time. So, you know, this is a good example of a multiple choice or a multiple prize situation, multiple ways to win, and choosing all the skill sets. This is why they put all X in the definition of expected value, meaning every outcome. But, you know, it's a positive expected value game, so it's not really a good thing. Now, I have to admit to you guys that this worksheet here that I have for you was a worksheet created by some of the publishers. It's kind of cheesy in a way. The publishers did that, not me. So it's kind of a cheesy example written by publishers. And publishers, you know, they do a lot of weird things when they write some of these questions and some of these resources. I never liked them, but I had to use them in the past. But that's okay. Some things are okay. Not everything. Yeah, that's the idea. But, you know, you did learn something about a positive expected value. We talked a little bit about a positive expected value yesterday. Let's see if you guys remember. Let's see if you remember yesterday. Positive expected value. What games have a positive expected value in Las Vegas? Should I sing that? You guys don't want to hear me sing. You guys remember? What game in Las Vegas can be turned to a positive expected value game? Maybe those people at home. Oh, let me double check. Yeah, I think there is an echo. Is there an echo for you guys at home? How you guys doing? Good morning, Ashley. Good morning, Linda. Yeah, is there an echo? Good morning, Lucky Huang. Shaksun. Good morning. Good morning, Brittany. Good morning, Monsi Herrera. I don't know. There's not an echo in my headphones, but there might be an echo in the room because while they installed this HiFlex stuff. You see, the school has decided to copy Mr. Judge and what he's doing. So there's this HiFlex. This is why you guys see there's speakers in the room. There's a camera, believe it or not. Anyway, this is the HiFlex system because they want to broadcast on Zoom the same way Mr. Judge is doing it for you guys here. So they spend a lot more money than I did to get that to happen. All they had to do is listen to me. They would have saved some money. But no. Anyway, copycats. Copycats. You guys know what I mean. They're copying Mr. Judge. They're finally getting a clue. Hey, they're getting quicker. I've only been doing this for like 2.5 years. And so by the time they do it, it might be a 3-year. They didn't even have websites. Look how old my website is. You guys know. You guys didn't even know. They didn't know how to spell website. Anyway. I like making fun of the school. It's kind of funny. So if you hear the echo, it's because, my voice is being piped into the sound system of the room. There's actually 4 speakers. The microphone is right there with that green thing. There's a lot of microphones. So even if you guys are talking in the room, because I was at a meeting yesterday for this HiFlex. So if you're talking in the room, it picks up your audio. If you're talking outside, it can pick it up too. That's what they told us yesterday. These microphones are very sensitive. I'm not using the microphones. I'm using my own. But the people that do use that HiFlex system, they're not using a mic. The mics are up there, and they're room mics. So when you're talking, they get to hear it. They hear what you're saying back there. Oh, Mr. Judge is the best. I wish we should go get him some breakfast or something. Some lunch. Or go get him a coffee. Oh, Mr. Judge. Hey, you guys saying that? Oh, that's nice of you. So these microphones can hear everything you guys are saying. Even outside the room, they told us. You guys know what I mean? I don't know. So anyway, they got a clue. It only took them 3 years. They're getting better. I think because they have consultants telling them what to do. You guys don't know this. Our district of administrators, you got this level of administration, but then they got consultants telling them what to do that they pay to do their job. Do you guys know that? So the consultants are pretty good. It only took them 3 years. Probably. That's okay. It's not libel if you're not lying. It's only libel if you're lying. You guys don't know that? Anyway. I love it. It's great. But it's okay. They're getting a clue. It's good for them. So some of your classes in the future might be HiFlex. You might sign up. I don't know. Do you guys want to sign up for these kind of classes? Or do you rather be face-to-face? Right. Right. And that's kind of why I do it. I mean, do you really want to be at home? What's the problem with being at home? Huh? You do it in the hospital? Yeah, you can. Yeah. Oh. What about you guys? You guys rather be at home or you rather be here? Oh, your sister's at home and she's annoying? Yeah, being at home might be too many distractions. You got your refrigerator at home. That's a distraction. You might be in the middle of lecture and you decide to go get some ice cream. You decide to make a quesadilla or something. You know what I mean? I'm gonna have a quesadilla. You know, I'm listening to Mr. Judge. Having some. I used to talk to those students when we were remote. I used to say, "Oh, you guys are probably some people were in their bed watching lectures." No, you guys don't know. And then I remember when some of the Zoom stuff, you get to hear the family arguing in the background. You guys know that? It was all the family arguing. You hear all the screaming. You hear the dogs next door barking. You guys know what I mean? Know this. HyFlex is more flexible. Yeah, I don't know. They get to I guess the camera gets to follow the instructor if the instructor uses the whiteboard, you know. But it's hard to see the whiteboard, but okay. So, you know, it has its benefits. Some people prefer class for a lot of reasons. I say if you you know what I think is important? You get out of bed, take a shower, brush your teeth, shave, get out of bed. You've already accomplished something in the day. You guys know what I mean? It's important to accomplish things every day. Make your bed. What do you mean? What's so important about getting up and making your bed? You accomplish something for the day. You start the process. That's important. Put your socks in your what? Hamper. You guys know what I mean? When you wake up in the morning and you shower and you got your socks, take your socks off, put them in the hamper. You go, why? Because you accomplish something in the morning. You start your day right so that you start accomplishing things every day. It's important. If you don't do it, you say you're at home and you're honestly get on my phone for a lecture, you know, HyFlex, Mr. Judge, whatever. Yeah, you might not even do your homework because you're not used to accomplishing things. You guys know what I mean? You got to get used to having some accomplishments. And that making your bed is that first one. Showering, combing your hair, you know, getting out of the house, moving. Get moving. So that's kind of why I like, well, I should say, I'd rather be face to face. I'd rather see people. Personally, I'd rather see people. I don't mind, you know, like if you look at some of the icons here, you guys can see the icons. I'd rather see a picture of a person because I'd rather see a person. I'd rather not see colors. Some people put colors, you know. It's okay. Some people put like cat figures. They put their cat. Some people put other icons, you know. But I'd rather see a picture. And I'd rather see a real name because I'd rather see a human being. I don't know. Maybe you're different. Maybe you say, I don't want to see a human being. Rather see a bird or a cartoon character. You guys know what I mean? You have a favorite icon? What's your favorite icon? Xbox? PlayStation 5? Which one? Yeah, again, I don't even know what that stuff is. Gosh. What is it called again? Magic the Gathering? Wizards of the Coast? I don't know what that is. Oh, it's a Dungeons and Dragons thing. Oh, okay. Anyway. So, ladies and gentlemen, let's go back. Speaking of homework, you say expected value. Do you guys remember the next lecture we did on the binomial? Remember the binomial distribution lecture? Okay. Now, let me go back to some notes for you guys. You're not in trig yet. You will be one day, hopefully, if they let you. You guys know what I mean? How do you get out of here? All right, I guess I have to do it this way. Okay. So I'm going to go to my notes because I sent that to you guys when we worked on the binomial. It's under the Statistics Online transition. So if you're looking at this, I want you guys to recall the notes. These are